Introduction. Purpose chromatography in forensic is to identify and verify sample of drug, ink, and also biological sample like saliva, urine, blood, and other. What is chromatography? A sample technique for mixture involves a mobile phase, liquid or gas, and stationary phase, solid or liquid. Components move at different speed, causing them to separate. What is chromatography in forensic? Detect and identify evidence substance, apply to drug, ink, blood, fiber and toxic, non-destructive and highly sensitive, quick and reproducible, admissible in court due to scientific reliability. This is a few methods in chromatography that been used in forensic science. First, GCMS method in chromatography in forensic science. This is a combined analytical technique that couples gas chromatography for separating compounds and mass spectrometry, identifying and quantifying them. This is one of the most powerful tools used in forensic science because of their high sensitivity, selectivity, and accuracy. Second, we have GCFIT, gas chromatography with flame ionization detector. This is used for identifying and quantifying organics like fuels, oil, and drugs. This is common in arson investigation and drug analysis. Then we have HPLC, high performance liquid chromatography. This is used to separating and analyze non-volatile and thermally unstable compounds such as toxin, dye, ink, and also biological fluid. This is common in toxicology, handwriting in comparison, and pharmaceutical analysis. And last but not least, LCMS, liquid chromatography mass spectrometry. This is used to detecting drug metabolism, poison, and steroid in blood and urine. This is highly sensitive, especially in biological sample analysis.
Now, let's take a look in the theory of chromatography being applied in forensic science. Forensic scientists use chromatography techniques to operate analysis by separating specific compounds from a mixture sample for forensic investigation purposes. Technique used includes gas chromatography, high-performance liquid chromatography (HPLC), and thin-layer chromatography (TLC). Gas chromatography paired with mass spectrometry is often used to investigate arson and identify drugs. HPLC often used for ink analysis in documents, whereas TLC is applied for preliminary analysis of inks and dyes. The important terms in chromatography are mobile phase and stationary phase. Mobile phase refers to an analyte mixture that moves through or over the stationary phase. Stationary phase is a porous or liquid-coated solid that is static and fixed in a place to absorb components to separate the compounds. Next is the use of gas chromatography technique in drug testing. Scientists in the lab receive samples such as blood, urine, and hair for drug identification. The reason for GCMS technique is applied in drug testing instead of other techniques is due to its many advantages. First, this technique is sensitive and accurate, which means each compound can be identified with high precision. Secondly, this technique is not limited to only one compound, meaning this technique does not have to be repeated for each different compound because it can identify many different compounds at once with only one run of the experiment. Third, the process of the drug testing is quick and does not take a long time to produce its result. This could help the investigation being held to continue to its next step smoothly. Last but not least, only a minimal amount of sample is required for drug identification, which is very convenient due to the limited sample collected by the sample collectors. Next topic is the methodology of chromatography technique in drug testing, specifically the GCMS technique. First, collection of sample and its preparation. Sample is collected and the existing interferences within the sample is eliminated from analytes of interest. One of the common preparation method is liquid-liquid extraction (LLE). This technique takes advantage of the different solubility of the drugs from biological matrices by separating them into different immiscible liquids. Another method is solid phase extraction (SPE). This technique uses a solid adsorbent to specifically withhold analytes followed by elution with a solvent. Last method is the quenches, quick, easy, cheap, effective, route, and safe. This technique is a simplified extraction method applied in forensic toxicology for drug analysis. The next step is the instrumentation and chromatographic separation. The prepared drug sample is injected into the GC system through the injection port, where samples are vaporized from liquid to the gas form and introduced into the chromatographic column. The column used in this technique is capillary column, a long and narrow tube coated with stationary phase, which either a liquid or a polymer that separate compounds based on its interaction with the stationary phase and their volatility. The vaporized sample transported to the capillary column by the mobile phase, which is the carrier gas, usually helium or hydrogen. The compounds eluted from the column and directed into mass spectrometer for detection and identification. The last step is the detection of compounds by mass spectrometry. In the spectrometer, ionization of compounds occurs by using electron ionization EI to produce charged particles. Next, the ions will be separated based on their mass to charge ratio done by mass analyzer. Lastly, the detector runs a measurement of the abundance of each ion and generates a mass spectrum. The end result provides detailed information for scientists to identify a specific compound and its quantity. This means this chromatography technique is a qualitative and quantitative analysis.
So these are example of result. So the first one is the collection of sample and preparation. So a 50 ml urine sample was taken from a suspected drug user. So this is only for an example. So then it will be broken down and run through a few different methods. So the first method is the liquid extraction, or LLE. Used a mix of chloroform and isopropanol 9:1 to pull out those non-polar drugs. Then solid phase extraction, or SPE, with C18 cartridges were employed to tidy up and focus on the basic drug compounds. And lastly, the Cassius method came into play for a side-by-side test on multiple drugs, honing in particularly on amphetamines and benzodiazepines. Next is the instrumentation and chromatographic separation. So the separation managed to reach baseline resolution for several drug compounds in just 20 minutes. So the first column HB 5 ms 30 meter times 0.25 millimeter times 0.25 micrometers, and for the carrier gas is helium at 1.0 mil over main, and for the injection volume is 1 microliter splitted. And for the oven program, the inner shell is 70 degrees Celsius for 2 minutes, and for the RAM 1, 25 degrees Celsius over minute to 150 degrees Celsius. For the RAM 2, 10 degrees Celsius over main to 280 degrees Celsius, which is hold for 5 minutes. So for the third part, for the mass spectrometry detection, so the ionization mode is electron impact EL at 70 eV. For the scan range is mass over the charge of the ion, which is 40 to 450, and detector is quadruple MS. For an example, methamphetamine has a molecular ion peak at m/c at 149. The measured peak from the sample was m/z equals to 149.3. So the first step is to compare m/z value with reference. So the acceptable tolerance is plus minus 0.5 m/z. So the alert range is 149 plus minus 0.5, which is equal to 148.5 to 149.5. So for the second step is to check the retention time. The reference retention time for methamphetamine is 45 minutes. The sample has a retention time of 4.5 minutes. The alert range is 4.6 plus minus 0.1, which is equal to 4.5 to 4.7. Because 4.5 is within the tolerance, thus the retention time matches 2. So they confirm the presence of methamphetamine in diazepam by looking at the retention time and the unique mass or fragmentation pattern. The peaks line up perfectly with certified standards, showing differences of only about 0.1 plus minus minutes and 0.5 plus minus mz. So the conclusion for this, the chromatography plays a crucial role in forensic science. It is all about separating and identifying substances in complex mixtures like drugs, ink, blood, saliva, and other biological samples. What makes it indispensable? Its incredible sensitivity, non-destructive approach, and quick, repeatable results. These features are just what investigators need when sifting through trace evidence at crime scenes. Forensic labs often rely on methods like GCMS, GCFID, HPLC, and LCMS. Each method has its own strength, tailored for various types of forensic analysis. All in all, chromatography is a major player in ensuring forensic examinations are accurate, efficient, and above all, credible.